All right, well, that was pretty good timing for this presentation because I'm also going to be talking about deriving. Not really adding a new feature, but more of cleaning up existing features. So, brief overview of what deriving is. Originally, it's conceived a way of eliminating some boilerplate for instances that you write a lot. So it can do a lot of things now. The traditional way you can interact with instances is you can derive some well-known type classes that have been made aware by GHC. So show is one of them. If you derive show, then it will basically stub out an instance for you based on what the structure of your data type is. That's one thing you can do. Also, if you're willing to enable some extensions, you can do some crazier things. Like if you have new types and you're willing to turn on generalized new type deriving, then you can generate instances for just about any type class you want as long as it's a new type. So if you derive num with this extension, then essentially it's going to generate an instance of this form, and it just works. And more recently, as of GHC 7.10, I believe, you can also derive instances for any class or any data type as long as you're willing to generate an empty instance. And this works well when you have default implementations of methods, like this really stupid example, textable. If you have some default implementation that makes sense for most things, then if you derive textable with the derive any class extension, then it will generate this empty instance, and when you call textify on the BAS value, then it'll print out default text. Fantastic. So we have all these cool features, but there's sorry, I didn't even show that. So we have all these cool features, but there's an issue in that they're not completely compositional at the moment, and it's hard to know which of these rules are going to fire depending on what you're trying to do. So as a quick quiz, does anybody know what gets printed out when you invoke main here?
42.
So, you would certainly think that it would be 42, but as it turns out, it's not. The reason is because show is a special type class, and when you derive show, it just assumes that you want to use the default mechanism of coming up with a show output that uses the structure of the type. So, as an unfortunate consequence, you can't use deriving show with generalized new type deriving, and that makes us sad. Another quiz, what does this do? Think carefully. So you'll notice I have both derive any class and generalized new type deriving on, which is a bit scary. And as it turns out, if you compile this, GC will kind of freak out a little bit because both strategies are valid, and it will default to derive any class, which is a bit of a dangerous choice because there wasn't a default implementation, so it crashes at runtime. Ooh, that's a bit scary. So as it turns out, GC has a way of figuring out which strategy you want to pick, and this is how it determines which strategy to pick. I don't expect you to be able to read that, and I also don't expect you to be able to memorize that because I certainly can't. It turns out there's a lot of weird things that GHC tries to do to optimize instances in certain cases, and as a result, it might pick generalized new type deriving even if you don't have the extension on, and it's got a lot of very complicated interactions. And you could imagine if we introduce some other deriving mechanism in the future, we have to integrate it into here somehow, and that sounds like a complete nightmare to me. So to avoid this kind of problem, my solution is to introduce some new keywords to help you pick which deriving strategy you want to pick. So if you have this language extension, deriving strategies, and you have a keyword, you can very particularly pick which strategy you want. So this example, this specifies I want generalized new type deriving, ignore any other language extension that might be on. So to review the things we had earlier, for the usual case when you have specialized type classes that GC knows about, use this bespoke keyword. I'm still a little iffy on the exact word to use, so if you have better suggestions, please tell me. You can say deriving bespoke show, and it will generate that. For new type, this was a pretty obvious choice. I use a new type keyword, so you can say deriving new type show, and this time instead of printing out that constructor name, it will just print out show X like you'd intend. It's fantastic. And then finally, for derive any class, you use the any class keyword. Pretty straightforward. So this is Slay the Land 8.2. Hopefully I'll get it merged soon. Thanks everyone.
Luke, you're up next.